Okay, I want to look at the tin for the John Deere 9770 kit in an assembly drawing and show some places where we can tighten up the some of the openings that occur in that tin. It's very difficult to make it fit absolutely tight around everything. There's some places that may leak dust in from the radiator fan blast and maybe allow some dust to get to the hot components. I want to start by looking at the tin assembly altogether, just to orient anybody considering doing this. The tin is shown here assembled, but of course the engine and all of the rest of the ancillary parts of the engine are not visible or are not here. This is just the tin, so it's a little bit misleading in that we've got a lot of stuff that's not shown here. But I can rotate the tin around and try and get us oriented. I am looking at this right now as if I was the radiator and the fan blasting air and dust at this end of the engine and then this end of the enclosure. I can rotate it this way, and now I'm looking down on top of the engine and the exhaust system. So we can use that as a way of getting oriented to where the parts are that we want to, and where the openings are that we want to consider trying to tighten up a little bit. The first one, and probably the most important one, is the area right in here where my cursor is. It's related to the part that's highlighted there and this part that's highlighted here. It's kind of this corner in this space here, and we're going to come back to that in a little bit, and I'll show you a picture that one of the machine owners has taken of that area, and we can show the actual opening that we would like to tighten up with some of that aluminum foil tape. So that's the first place that we want to look at. The second place that we'd consider is this brown, color-coded brown piece here. It's a filler piece that screws down to this flat piece underneath here, and it fits up against the turbocharger compressor that compresses your fresh air. What I'd like to look at there is the possibility of sealing around this edge to the compressor. I don't know if that tape will stick in the long term to that compressor or not, because it gets quite warm, but it would be nice to be able to seal this up against that. It should fit up against the face of that compressor, but there may be a little bit of gap there. And in all cases where we've got air blasting from our point of view here, in this against these parts, any opening here may allow the radiator fan blast to push some dust in there. So we'd like to tighten up any openings that face towards us here on the kit, because they're a possible source of getting dust inside the enclosure. If the dust gets inside the enclosure, it's going to eventually find its way to the turbocharger and the hottest parts of that system, and it probably will ignite and cause some little sparkles or dust particles to ignite. And if that happens, eventually some of those could get out of the enclosure and land on a dusty surface. So we'd like to tighten those up. The other benefit from tightening up these openings is that it causes the air that's being pushed in there to find other places to go, and so it will leak out other small openings and prevent dust from coming back in there. So the more we can tighten this up, the more we keep it pressurized with clean air, rather than allowing a lot of air to leak out one spot and then maybe another spot has low enough air pressure that the radiator can push some dust back in there. So the first place we're going to look at eventually is right up in here where my cursor is, that space there, because there does seem to be a little bit of an opening there. It's very difficult to close that up entirely in the design. Maybe in some future design I'll have tin that fits perfectly there. And then underneath this, potentially this curved area up against the compressor housing face. Another thing we want to make sure is that this piece is screwed down tightly to underneath. It looks like in the pictures that I have that it's still screwed down tightly there, but we want to make sure it stays put so that it can't rattle loose and create an opening there. Another area, potential area of leakage, is over here on this opening right up in here, where this is where the pressure line to the turbocharger bearing comes in. John Deere runs that pressure line all around the engine or all over it. We end up encountering it about 3 or 4 times on this tin kit, but it comes up through here where my cursor is moving, and then reverses direction and goes in through that opening to the turbocharger bearing. In the picture we have, it fits pretty closely right underneath this right here, but there is some space underneath it that's open here, and if I were going to patch this up or tighten it a little bit, I would try to fit some of that aluminum foil tape right underneath that bearing line or that oil line right here to minimize the amount of open space around it there, so that we don't leak any more out there than is necessary. Also, it may be possible, let's see if I can get this rotated so we can see it. There we go. The compressor is right in here, that donut shaped turbocharger compressor, and the air line, that the compressed air leaving the turbocharger is coming out right down through here. There's these pieces in here are there to allow that large rubber fitting that's connected on there to nestle in there. But I would like to be able to, for instance, fit some tape in here and tighten this space up a little bit if possible. That's a pretty tight space and it may be difficult to get tape in there, but if it's possible, I would do that to plug this up a little bit more. Pretty much, and that tape can't really hurt us anywhere, I don't think. These aren't moving parts in here, and so just filling it with that tape, that aluminum foil tape, so that it prevents air infiltrating in or getting pushed in there is a desirable thing. But in the picture that we're going to show, you can see that oil line. It actually comes up out here and then reverses and comes back in through here, and we would like to be able to tighten up underneath there with maybe a piece of tape or two right across the bottom of this opening. So that's another one. We'll show that in a little bit. Probably the third area that I'm going to show is on this end. This is the radiator end. I don't know if I can get this rotated around any better than this. There we go. Yeah, a little bit better. This piece here has a opening in it for it's actually a coolant line that comes out of your exhaust gas recirculation cooling system, and comes out of here and makes a corner, makes a bend. But this piece, there is a little bit of an opening around that tube. It's very difficult to know exactly where to cut this hole so that it hits your particular tube just exactly in the middle. So we make it a little bit bigger than is necessary so that we know that we can clear everything there. But you can tape this up as tightly as you can around that tube and it won't hurt anything. It just prevents dust from getting in there. Right now, when I look at the pictures, there's a little bit of opening on one side and a little bit of opening on the other side, and that could allow the radiator to force some dust in, air and dust in around that tube. The other place in this end that it looks to me like there's a little bit of an opening is right up in this area up here, and so that part of the tin kit is just not quite tight there, and we could perhaps put some tape across this area in order to preclude anything from getting inside at this point. This is at kind of the end of the exhaust manifold, so it's probably not the hottest part of the entire engine, but I still don't want any dust getting in there because it could accumulate in there and then eventually cause a problem. I think I have one more place where we have a picture that would show us a place we could tighten it up. There is an electric sensor. I think it's a temperature sensor probably that goes right in through this little hole or little opening. And so in the case of the picture, there's a little bit of an opening at the top right above that sensor. It would be pretty easy to put a piece of tape across the top of that to tighten that up. This one, the air is moving past this hole from the side because it's moving left to right here, so it's not really being forced into that hole as much, but still it'd be pretty easy to tighten that up. And like I said, anything that tightens the enclosure up is really beneficial to us because there's going to be plenty of places for air to leak out. We just would like to minimize those in terms of allowing air to leak out so that we keep it pressurized as much as possible. Now there's a couple of places on the enclosure that I don't have good pictures of on the installation, but I'm going to show you a couple places where you might be able to tighten it up anyway. This would be the back side, or the side towards the back of the combine, right on the right above the engine head. Engine head would be right where I'm circling the cursor here, and the exhaust system, turbocharger inside here, an exhaust pipe running here and coming out this end, and then muffler is right here. So we're looking at this back side here, and there are two openings in here, and again, it's one of the things that goes through both of these is that turbocharger oil line that they routed comes up through here, passes through here, runs along here, and then dives down through here again to go underneath the turbocharger compressor, and then loops back up and around and into the turbo bearing. I would like to be able to tighten up this opening here. Because we're pushing air in right up here, it could turn around, a lot of it could turn around and come right back out here. And so there's an oil line going through there. They're all stationary parts. You should be able to, if possible, put a little of that aluminum foil tape around this pipe going through here. Tape it up as much as you can so that it can't allow air to get actually what we're really trying to do is prevent air from coming out there so we don't lose that air. Also, I don't know if it's going to be possible, but there's a whole chunk of stuff right in here, and this whole thing is designed to try to fill in and fit around that. But anything you can do there to tighten up this so we don't lose air in this area would be desirable. So any of that tape that you could put in there. There is a moving part inside this that runs up inside here and controls the geometry of your turbocharger. And so that has to be free to move, but everything here is designed to fit around that so that it doesn't interfere with it. On this end, this opening here with these fingers, that surrounds both that oil line coming through here and a part of the wiring harness that comes out through here. And so we do need that to be able to come through cleanly and not disturb it in any way. But again, I would be inclined to use some of that aluminum foil tape, and if I haven't already done that on this particular machine, I would try to tighten that up with some of that foil tape so that we don't short circuit air blowing it in this hole and turning right around and coming back out here and not doing us good somewhere else. So if possible, put tape around these pieces coming through here and reduce the amount of open space around those things. Again, the tape will just keep them from vibrating and probably kind of protect those parts anyway. So I would use some of that foil tape here to try and tighten that up if I was going to try and improve that system. So those are the areas that we can look at. I don't have any other ones on here. There are pictures that have been sent to me of the bottom, but they don't look too bad. The oil return line comes out through here, and there isn't a lot of space there for dust to get in. Also, the air blast is moving across the underside of that box, and so I don't think it's pushing much dust back in there. The rest of this looks pretty good, but those are the areas that I want to try and fix, and I want to try and show you pictures of each one now. So let's go back to the first one we were talking about. It would be right up in this area, and now I'll try and switch to a picture of that area and maybe talk about that some more. Compressor housing, that's this green donut, looks like a giant raised donut here. You're seeing part of it, and the area to the above and to the left of that, the dark area, as that there's a sensor line that hangs across the opening there, but that dark area is the first area that we talked about on the CAD model that I would like to tighten up if possible. I can't show you a cursor in this image. It shows for me, but it won't record the cursor position on there, so I just have to talk you through this one. That dark area up above is the area we'd like to put some tape, foil tape across, and so you could go aluminum piece to, or excuse me, galvanized piece to galvanized piece across that. Any way that you can tuck tape in there to reduce the amount of opening in that space. That to me looks like probably the first place to work. There's kind of a vertical flange in there, and then we've got the wall that we're facing of the box that encloses the exhaust pipe and the exhaust turbine, and then we've got in the upper left hand corner those tabs that help box in that turbocharger actuator. But that gap in between there is the space I would like to bridge with foil tape any way you can do it. I don't really think there's a wrong way necessarily to do it. I don't think you can hurt anything there. There is one moving part, but it's back in behind there, and you couldn't get tape to it from here if you wanted to, I don't think. So if you can fill in that space somewhat with that foil tape, probably have to clean the surfaces off in order to be able to make it stick a little bit, but be able to fit some strips of tape in there. You can fit them. They will because they're foil, they'll mold to the shape to a certain extent, and that they're real sticky. That adhesive is real good on there, so you can goob them on there or stick them on there and then flatten them as much as you can. Don't be bashful. Anyway, I don't think there's a bad or a wrong way to necessarily do it. The other area that in this view that is you could look to potentially improve the situation just a little bit is the galvanized fitting in the lower left here that fits up against the outer part of the compressor donut. It fits underneath the black rubber hump connector that's in the foreground in your picture. Has a flange on the bottom that screws down to the flat deck of galvanized that's on top of the head, and this piece wraps underneath that green donut and around to the right side a little bit, and it should ideally fit flat up against the face of that donut, but it wouldn't hurt if it's possible to get some tape on to actually link it to the donut. So if you could stick some tape on the left side and underneath there to actually seal it up against that green donut, that won't hurt. Also around the kind of the left end of that part where it wraps around the donut, it actually has a 90-degree bend to fit around something that's round, so there's a little gap in there anyway, but you could tape it on there as well just to try to seal it up. That wouldn't hurt at all. Also, that piece fits up against the green, or close to the green box that's on the left side of this image, and if you could clean that box off and put a piece of tape between the aluminum, or I keep saying aluminum, but galvanized piece and the green box, that would help to seal that up there so we can't get dust through behind there and into the space we don't want it to be. Anything you can do there to put tape on won't hurt anything. It just helps to reduce the amount of air and dust that could get in it from the radiator side here. So that's the compressor that we're looking at there, and that piece that wraps underneath it, we would like to make sure that that stays put. Also, you want to make sure that that's tight down to the box, to the deck underneath it, so that it's not loose. It doesn't look to be loose in this case, but just want to make sure that it stays tight. That's part of the reason we use that tape on top of the screw heads, is to act like a Loctite to keep them from vibrating so that they can't rattle loose in that sheet metal. So you could put tape down on those, over those screw heads while you're there doing that too. It won't hurt anything. So that's those first two places. Probably the most important one is the upper left hand corner of this image where it's dark there, to try and fill that space or bridge across it with foil tape. And then this piece that fits underneath that rubber hump connector up against the turbocharger compressor, if we can tighten that a little bit, it wouldn't hurt either. Get oriented here again. So that was looking from the radiator end. The next end I want to look at is down here. This is the end right closest to the radiator fan, and we've got cast iron end of the, I think it's the end of the intake manifold or something sticking out here, and we tried to fit up tight against that and over against the block on the left side here, but we've got some gaps down here and maybe some gaps in here to fill in. So let's look at a picture of those and see what it looks like. This is the view from the fan, the radiator fan, towards the engine. You can see that curved line coming out this end. That's that coolant line that's part of your exhaust gas cooling system, and you can see that there's a little bit of a gap on either side of that in my tin, or in the tin, and it's not been taped up real tight there. Also from that tube, if you go up and left, there's a dark area there. That also probably represents a small opening in this part of the tin kit. It should not be a very big opening there, but it does look like there's some space there. So these are two areas that I would try to clean off first with some kind of mild detergent water or solvent like paint thinner, gasoline, something like that, to take that sunflower dust residue off there and get a clean surface so that we can get the tape to stick on there. And then I would use some of that foil tape and tighten up the opening around this coolant line, because we're facing right at the radiator, and so while we're pushing air in with our blower elsewhere, clean air into the enclosure, the fan is trying real hard here to blast dirty air into that part of the enclosure. And although I think our fan is pretty powerful, still it's a long ways away from here, and it's got a lot of convoluted spaces to go to before it gets down to this end. So the pressure, we may not be winning the battle at this end is what it amounts to, and so the best thing we can do is close that space up so that the radiator fan can't blow air and dust into those spaces. So I would clean them off and use several pieces of that foil tape to tighten up the opening around that tube, and also to bridge across the opening and up and to the left there. If there's any space there, we can just bridge across that with that foil tape, and it will keep dust from blowing in that location. So that's on this end. That's the second area that I would definitely try to achieve that improvement or that remedy to keep dust from getting in that part of the enclosure. Let's go back to our model. Okay, so if we get this end, that's right here and right in here that we were going to put tape on to try and tighten that up a little bit. Anywhere else you see where there's an opening around here where dust could get in, you can also try to add tape to tighten it up. Now I'm going to swing around to the view that you would have if you're sitting on the rotor sheave, the pulley that runs your threshing rotor, with your back against the grain tank. This is what you would see if you have the shielding off in between, and that's the easiest way to access this, is to take that shielding off. It's a few 8mm bolts that take a 13mm wrench, and there's a handful of those that hold that those shields on. Then you can access all of this pretty easily once that's off. With those shields on, it's going to be quite difficult to reach in here. You could go down from the top, but you can't hardly get in from the sides. So if we're looking at this area, again, we're back here is where that pressure line for the turbocharger bearing comes up and then reverses and goes through here. And I want to look at a picture of that one and on an actual 9770 and show you how to tighten that one up. You're looking at the oil pressure line that serves the turbocharger bearing. It's looping up from below the turbocharger compressor housing towards the grain tank in this area, and then it reverses and goes back and points towards the turbocharger bearing from the grain tank side. And so it kind of comes through this space between the tin and then plunges through this hole that we have in the tin kit there with the pedals cut in it to give us the ability to flex it around that tube. You can see in the middle of the image that there's a gap where it loops back in, and my goal here would be to clean the tin off and then to take at least 1 or 2 strips of that tape and try to get it underneath that oil line and bridge across that opening so that we just reduce the size of the hole that's here around that, just to reduce the amount of air that's lost at this point. The air entering our enclosure is not very far from this. It's right on the other side of the turbocharger bearing from this, and so I don't want too much air just blowing through here and blowing right out here. It won't hurt to put that tape across there. Again, these parts aren't meant to be moving or anything like that, so it won't bother that. There is a sensor line. It's a little electrical line with plastic insulation or shielding on it behind there. We have to work around that or make sure that we don't interfere with that, but we could put as much tape as is necessary along this hole and underneath that tube or that oil line and across that hole to try to close that space up as much as possible. Down below where that line goes through, it might also be possible to get a strip or a piece or two of tape in there and tighten up that space around where that pipe plunges back down into the underneath the compressor turbine there. So you can put as much tape as necessary on here to try and tighten this up. It won't hurt anything. It'll just keep us from losing as much air out this part of the enclosure and keep pushing air to other parts of the enclosure, which is what we want to do. So that's the next place to address. This one shouldn't be too hard to reach. If you have the shields off between the grain tank and the engine, it's right there in front of you. It's right easy to reach at. If you're on top, you may be able to reach it from above, but it's certainly easier to reach it from the grain tank side. So that's one to add a few strips of tape to. This is that space we were talking about. That line comes up through here, reverses and goes in there, and if I could fill in right under here a little bit, I would. Also, if I could get tape down in there to connect these two parts, this one here and this one here, that would be desirable because we probably have a little bit of a gap here, although it isn't probably very much, but there's a tab here that goes back in at kind of in the inside of the turbocharger compressor, but anything we can tighten up would be a good thing. The last one that I have here to look at, where I have a picture of, is this sensor area right here, where we have an electric sensor going through there, and I'll show that one in a picture. Okay, now we can see that here's this wiring harness piece comes around here, and there's a plastic snap-on connector here, and I put tape around much of this when it was first assembled. You can see the tape here and the tape up here. It stayed put pretty well, but there is a little bit of a hole on top of the sensor here. I don't think this one leaks too much because the air blast is going left to right straight across here rather than blowing at it, but still, if I was in there, I would simply clean this off, take a strip of tape and put it right down close to the sensor and plug that hole up so that we don't lose air around that sensor there and can't get dust back into it. So those are the ones where I have pictures of this system. You can see the dust that's accumulated on here. That's sunflower dust, I'm sure, that sticks to everything. I don't know what the best media is to get it off. I'm sure soap and water will take it off, but anything that would take that off of there, whether it's a mild solvent like a little bit of paint thinner, something that would evaporate cleanly is what you'd like. Even gasoline or something like that might be a good way to strip that off, and just some paper towels and clean it off. Or light dishwashing detergent and some water would probably take it off as well. But you can clean that up and then put a little bit of that tape on there and tighten that hole up. Let's go back to the model one more time. Okay, I'm going to rotate around to the back side and suggest one more time. I don't have pictures of this one, but if you look down straight on top of this enclosure where your air comes in here, this is where your air is going to come up and turn a corner and come into this enclosure. You're going to have a hole back here with a electric harness coming out of there and an oil, about a 3/8 inch diameter oil line coming through there, and that oil line runs along and then dives back underneath here. And if I was there, I would try to tighten up both of those spaces by simply applying as much tape as necessary to go over those areas to try to restrict the airflow that's allowed to leave at those locations. By doing that, we force the air to go to all of the small holes all around the kit to leak out that way, and that's a better way to flush the whole system and keep the whole system from getting dust in it. Once you have this thing tightened up, then we shouldn't have fires that start from the exhaust system anymore. The only other potential for exhaust related fires would be the muffler itself, which is out here to the left end of this enclosure now. Under most circumstances, I don't think that the muffler, most of the combines I've ever worked with, the muffler doesn't get hot enough to ignite the dust on contact. If you get a lot of dust accumulating on it, it could be that over time it gets hot enough that it starts to cook some of the dust on it and cause it to smolder on there, but it won't ignite on contact the way it will when it hits the turbocharger here when the turbo is running hot. So that's the reason we haven't tried to enclose the muffler itself on a 9770. I cannot guarantee that you're never going to have a fire on the combine. This system is designed to stop those instant fires that occur with the turbocharger and the exhaust manifold and that first piece of exhaust pipe here. And it should do that if we keep it buttoned down so that we can't get dust blown back into these small openings that exist around the system. Or on the kit. So this if you're struggling with still having some smolders on the combine, these are the areas that I'd look to tighten it up in addition. And if you're putting a new kit on, I would look at this video and say, okay, while everything is clean, I'm going to put on tape wherever necessary and tighten this up here. I'm looking at this part of it right here, and although there's a bunch of stuff here that you can't see because it's part of the machine that's not shown, anywhere I could tighten this enclosure up here, I would do it. You know, a hole that's a 1/4 inch diameter hole isn't going to be a big deal for us, but when we have a bigger gap like we see right in here, then that's a potential leak spot that we could get actually dust forced back into that area. So please be careful. Be vigilant for other sources of ignition on your combine, such as a failing bearing that will run hot enough to ignite dust. Your alternator can throw sparks, particularly if it's starting to fail. You can have an electrical short, but sometimes those things would show up as a fault somewhere else in the machine. But be vigilant for those, and then keep this system buttoned down, and it should stop the fires that occur at the exhaust system.